Section 12.5 is another form, exponential form. Here, the exponential form, you're using e. E is the base of natural log. On your calculator, you won't need to use that for anything. There's a lot of talk right now with exponentials with the disease going on. But if you look on your calculator, the ln, you should see a e to the x right above that. But anyway, the form is magnitude e raised to the theta j power. R is the magnitude, theta is your angle, and for this particular form, the angle is a radian number only. So express in exponential form, given 2 cosine 40 plus j sine 40. The 2 on the outside is the magnitude, or r, in this form. The 40 degrees is theta, but it's not in the correct form, so I do have to convert it to radians. So I take 40 degrees, I multiply it by pi divided by 180 degrees, and that comes out to 0.698 radians. So when I put it in exponential form, I put the 2 in front of the e, e raised to 0.698 j. Convert 0.33 cosine 280.6 plus j sine 280.6. Again, the magnitude is the number out in the front, so that's 0.33. The theta is my angle, which is 280.6, but again, it's in degrees. I have to convert it to radians. So I take 280.6 times pi over 180. That comes to 4.9 radians. So the form is 0.33 e raised to the 4.9 j. Express in exponential form. This time I have it as 0.329 at an angle of 46.3, which is basically the same form as above, just omitting the cosine and sine. So the 0.329 is my r, theta is 46.3, but again the 46.3 needs to be radians, so I take 46.3 times pi over 180, I get 0.808, so the correct answer would be 0.329 e raised to the 0.808 j. Please watch how they want you to round in this section. Let's try another one. Express in exponential form. This time they give it in rectangular form, 3 plus 5j. So this is not the correct form. I need the magnitude out of this, and I need the angle. Notice to get the magnitude, it's Pythagorean theorem, 3 squared plus 5 squared, so that's the square root of 9 plus 25, so that comes out to about 5.83. The angle is inverse tangent of b over a, so 5 over 3. Again, this is quadrant 1, 3 is positive, 5 is positive. So when I take the inverse tangent of 1.67, it gives me approximately 59.4 degrees. But I need that number in a radian number. So since I had my calculator in degree mode, I do need to convert this to radians. So I take 59.04 times pi, divide that by 180, and I get 1.03. So that was 59.04 pi divided by 180 to get the 1.03 radians. And then finally I put my magnitude here, e to the 1.03 j. This is my theta, this is my magnitude. Let's try another one. Express in polar form. Magnitude and angle, again this is degrees, and rectangular form. So this time they give it to me in exponential form. So I just need to pull out the correct information and get everything in the correct form. So the 75 out in the front is the magnitude, and the 0.8 is my theta. However, the 0.8 is a radian number, so I want to convert that to degrees. So now I'm going backwards. So I take 0.8 times 180 divided by pi, and that gives me approximately 45.84 degrees. So the polar form, I pretty much just take the magnitude, put it in front of the angle sign, and put my correct measurement that I just calculated as 45.84. Now that I want to get rectangular form, I just expand this out, and I go magnitude cosine sine, so it's 75 times cosine of 45.84 plus j sine 45.84. So that gives 75 cosine 45.84 plus j sine 84. Taking the cosine of 45.84 degrees, multiplying it by 75, I get 52.25. Then I take the sine of 45.84 degrees, multiply that by 75, and I get 53.8. Make sure you're taking the cosine of 45.84 degrees, not the cosine of 75 on your calculators. So if you're not getting these numbers I'm getting, you might be taking the sine or cosine of 75, not of the actual angle. But anyway, the rectangular number would be 52.24 plus 53.80j.